Hey guys, Catlin here with your homework help this week. First week back from spring break, we're looking at practice problems 8-1 through 8-4. Let's start with lesson 1. Lynn is interested in how many of her classmates watch her favorite TV show. So she starts asking around at lunch. She gets the following responses, and then you see the list of responses there. If she asks one more person randomly in the cafeteria, do you think they will say yes or no? This one is a do you think, so there's really not a wrong answer here. If it was me after assessing her results, it looks like she's getting a strong number of no's. It looks like 4 yeses, and the rest of them are no's. There's 4, 7, 8, 9, 10. So 10 no's. So based on what she's collected so far, I'm feeling like that she's going to get a no because more people have said that so far. That's what I would put. Of course, you could kind of put that in your own words more eloquently, I'm sure. Engineer tests the strength of a new material by seeing how much weight it can hold before breaking. Previous tests have held these weights in pounds. So they did a test. It didn't break until 1200, 14, 13, 15, 950, 1600, 1100. And our question is, do you think that this material will be able to hold more than 1,000 pounds in the next test? Well, considering that 1, 2, 3, 4, 5, 6 out of the 7, 6 out of the 7 were a yes. So I think it will. History shows that majority of the time it's being able to. There's only one happenstance where it wasn't, so I'm leaning toward yes. Company tests 2 new products to make sure they last for more than a year. Product 1 had 950 out of 1,000 test items last for more than a year, and product 2 had 150 out of 200 last more than a year. If you had to choose one of these 2 products to use for more than a year, which one would you choose to last longer? Explain your reasoning. So, product 1, let's do a little comparison here. What is higher on the probability scale? Is 950 out of 1,000 greater or less than 150 out of 200? Okay, they're both 50 short of being a full, but this full over here is less than this full, so the 50s kind of carry different weights. If you were actually to simplify them down to lower fractions, this one would be 95%, 95 out of 100. And this one would be the same as 15 out of 20, which is 75%. So product number 1 appears to be more reliable for lasting longer based on the percentages and the odds. Number 4 is a callback problem to surface area. Here's the formula for surface area. It is the perimeter of the base multiplied by the height plus the area of the 2 bases. So EH plus 2A, and these are being multiplied here. So let's start with identifying the base. So the base of this is this section here. That's the base. So we need to find its area and its perimeter. And then, of course, we will need the height from base to base, which is here. All right, so let's read this and see if we can get this figured out. Small staircase is made so that the horizontal piece of each step is 10 inches long. Okay, so the steps from here to here are all 10. So this is 10, this is 10, this is 10. That seems about right. You know, it's big enough for a foot to get on. 25 inches wide. So from here to here is 25 inches. We just found our height of our prism. It's 25. I'm going to go ahead and plug that in over here. Plus 2A's. Okay, and let's see. Each step is 5 inches above the previous one. So that tells us that this is 5, this is 5, this is 5, right? Okay, to help me with this one, let me move my face. Get out of here, face. Let's draw the base. Let's break it up. This will help, I think. Here's the base. Wham, bam, thank you, ma'am. It's 3 steps, right? We know that 5, 5, 5, which makes this 15. We know that this is 10, 10, 10, which makes this 30, right? So let's start with, I guess, the toughest one would be the area, even though they're both really easy. I'm going to break this up into rectangles. This is a 5 by 10, so this is 50. This is a 20 by 5. This is 20 here because 10 and 10. 20 times 5, that's going to be 100 square units of its area. And then 30 times 5, that's the big daddy right there. That's going to be 5 times 3. Let's see. 5 times 3 is 15. And then we add the 0, so 150. So units squared. Okay. So these are my areas. So my total area would be 50 plus 100 plus 150. And that's going to give me 200, 300. So 300 units squared. All right, so I've got 300 square units in this section right here. So 300 units squared. And that's my area, so 300. And now I just need the perimeter, so let's set this up. We're going to add all the way around the shape. We don't want to leave anything out. We got 10. We got a 5. Another 10. Another 5. Another 10. And another 5. Right? And then a 30 and a 15. A 30 and a 15. Sheesh. Okay, so 15, 25, 30, 40, 45. Okay, so all of this makes 45 plus 30 plus 15. These two, I like putting these two together first. 45 and 15 make 60. 60 plus 30 is 90. Okay, so my perimeter is 90, so that's going to go over here. Perimeter is 90. So I've got to do 90 times 25 plus 2 300s. So 2 300s would be 600s. And 90 times 25. Let's do that real quick. Do 25 times 9 and add a 0. 18 and 4. Okay, so 2250 and 600. Goodness gracious. That would be 2850 as my surface area. And this is in inches squared. 2850. Boom. Man, that was a tough doozy on the first page. Took a little longer than I anticipated because we had to break it down into shapes, but not that bad. Well, there you go. There's help for your first page of your homework.